Okay, we will go through the exemplar problems in the class 11 physics chapter 4 motion in a plane. Okay, before going through it, I will show you some information which will be useful. So this is the sine wave. So sine 0 is 0, sine 90 is 1, sine 30 is half, sine 45 is 707. Okay, 0, 90, 180, 270. So the 270 is minus 1. So the cosine wave is 90 degree shifted. That is sine 90 is cos 0. Okay. So cos 0 is 1, cos 90 is 0. This is minus 1. So you can see this. So this is sine and this is cosine. Okay. Now if we have two vectors A and B, then you find the dot product A dot B equal to, so this is A1 B1 plus A2 B2. Okay, this magnitude of A, magnitude of B cos theta. This dot product is a scalar one, and A dot B equal to B dot A, commutative and distributive also. When you do dot product of the same vector, then you will get A square. Okay. Now cross product A cross B equal to C, that is a vector, and this is magnitude of A, magnitude of B. This is sin theta, is a vector. Okay. So if you have two vectors A and B, then angle theta between them, then you see this is magnitude of A, magnitude of B. A dot B will be maximum because that is a cos theta. Okay, A dot B is AB cos theta. Cos theta will be maximum when theta is 0. Okay, when theta is 0, cos 0 is 1. So that will be maximum. That means when theta is 0 means two vectors are parallel. So you will get A dot B maximum when A and B are parallel. So that is theta is 0, cos 0 is 1. Okay, similarly when you do A cross B, that is sin theta. So here theta is maximum when theta is 90 degrees, so sin theta, sin 90 is 1. So here A cross B will be maximum when theta is 90, that is both are perpendicular. Okay. A cross B equal to minus B cross A here. Okay. For A dot B equal to B dot A, but A cross B equal to minus B cross A. A cross B plus C equal to A cross B, this is same. And if you cross multiply the same vector, you will get 0 because this. Okay. So sin 0 is 0. Okay. Now if we add two vectors, let us say A and B. So this is the resultant vector A plus B. Now A is in this direction. From the tail we are starting the B and it ends here. And the resultant should start from this end. That is the starting of the A and this. And if you start the resultant vector in this is wrong. Okay. So A plus B. So the resultant vector start from here and end here, this direction. This is A plus B and this is wrong. You should not start from here. Okay. You can also add the vectors like this. So here magnitude square root of A square plus B square. Look at the theta. Theta is from this B vector corresponds to B. Here is the theta. So tan theta is A by B. Okay. This is the theta. Okay. Now find the angle between A, the vector I plus A. So we have to find the dot product as well as the cross product. Okay, of the vectors. So cos theta equal to see a cross a dot b equal to magnitude of angle cos theta equal to a dot b. So a dot b, how will you find out? So this is magnitude of a, I plus j, 1 square plus 1 square is root 2. Okay, similarly b, that is also root 2 because we are taking the magnitude. Now a cross b is 1 minus 1. Okay, a dot b, I plus j, I minus j. So I and j 1, 1 into 1, then 1 into minus 1. Okay, because in the question this is minus. Okay, 1 into 1 plus 1 into minus 1. Okay, so then it will become 0. So now you substitute a dot b is 0 and into square root, this will be 0. When that cos theta will be 0, when it is 90, then only it is 0. Okay, from the cosine wave I showed you, when cos theta is 90, then it is taking the 0 value. So now the theta is 90. Which one of the following statement is true? A scalar quantity is the one that is conserved in a process. Which one is true? Okay, a scalar quantity is the one that never take negative values. A scalar quantity is the one that does not vary from one point. The scalar quantity has the same value for observers with different orientation. So scalar is having only magnitude, there is no direction for the scalar quantity. That is why same value for observers with different orientations on the axis. Okay, this is the one. Figure 4.1, the orientation of two vectors are given, x, y. Which one of the following is correct? So in this vector, both x component, y component both are positive, and for this vector only x component is positive, y component is negative. So this vector, so this will be y component, this is q is negative, and this is the answer. Okay, 3. Okay, here for this both x and y are positive, and for this vector we have x positive but y is negative. Okay, .4 the component of the vector are along the x-axis will have the maximum value. X component, a vector or x component is represented by the r cos theta. So if for r cos theta, this will be maximum when angle is 0, that is on the x-axis only. So 4.4. So here this will be maximum and theta is 0, cos theta is 0. Okay, this is x component, this is y component. When cos theta, then theta is 0, that will be maximum. Horizontal range of the projectile fired in this. Okay, book page 14. So you can go to this similar problem is mentioned here, so you can go through it. So 100 meter. Consider the quantities pressure, power, energy, impulse. So read the all except these all scalars. Okay, only impulse and area they are vectors. These pressure, power, energy, all these are scalars. Okay, impulse and area are vectors. In a two-dimensional motion, instantaneous speed is a positive constant, then which of the following is are necessarily true? Speed is a scalar, while velocity, acceleration and displacement are vectors. Okay, and the average velocity is not zero at any time. Average acceleration must always vanish. Equal path lengths are traversed in equal intervals. Okay, the important thing is this is a scalar and velocity, acceleration, displacement are vectors. Equal path lengths are traversed in equal quantities. In a two-dimensional motion, instantaneous speed usually is a positive constant. Which of the following is are necessarily true? Okay, the acceleration particle is necessarily in the plane of the motion. 3 vector A, B, C add up to 0. So find which is false they are asking. Okay, see in question 26 they were given which is false. Okay, 26. See, they are given some vectors. See how A plus B equal to C. This one, A plus B equal to A plus B plus C equal to 0 also they are given. Okay, so see this. So second, because this is coming in the opposite direction, resultant vector is opposite direction. A plus plus means actually it has to go from here, but it is coming. So you can go through these different vectors. Okay, it is found that A plus magnitude of A plus B equal to magnitude of this necessarily means this anti-parallel means they are 180 degrees. Okay, these vectors you can see the how it this proof from the net also. Two particles are projected in the air with the speed and angle this much horizon respectively. If the height is reached by the particle greater than the second, then the right answer we have to choose the right answer. This is the angle of projection, time of flight, horizontal range. There are different formulas are there in this. Number 11. Okay, see here if you look at this height, in a height, maximum height, so here theta is directly proportional to the theta. They are saying this is the acute angle. Okay, acute angle means less than 90 degree. So I have shown you the sine values. Okay, from 0 to 90 sine values keep on increasing. So when theta increases, sine value increase. Okay, so this is directly proportional. Okay, so this one is correct. Okay, this one is correct. And in terms of time of flight also the same thing. Time of flight here also you see sine theta. So theta the acute angle 0 to 9 theta increases, this will increase. So this is also correct, but these things we have 2 theta that will come the other side of the after 90 it may come. Okay, So here we have 2 theta. 2 theta means, suppose say sine 60 means 2 theta is 60 means 2 theta 120. That will come on this decreasing slope of the sine theta. So this may not be correct. Okay, these two are correct. So you can refer to this net for these things where particle is shown is frictionless thing. You can also read the book. Following are 4 different relations about the displacement, velocity, and acceleration for the motion of the particle in general. Check which is the incorrect they are asking. This one is incorrect, so you can go through the answers. For a particle performing uniform circular motion, choose the correct statement. Okay, these are the things are correct in the book 17. So here in the circular motion, okay, see they are given which direction is the acceleration, all those this information they are given. You can go through it. Two vectors a and b, a plus b equal to a minus b. That means these two are the correct. Okay. So that the perpendicular, this perpendicular, or one of them is 0 or 0. Okay. 4.15. Okay, so now if we say a square plus b square resultant cos theta, so when cos theta is 90 and cos 90, then it will be 0. Okay, this cos of 90 is 0, then this term will be 0. So that is if a and b are perpendicular. The cyclist starts from the center whole circular path of radius 1 kilometer and goes through this thing. What is the acceleration? That is also in the uniform circular motion they is given 17. So here it's given. Okay, so this one, this is the formula. Oh, that's 16. 16, 25 also same thing. A particle is projected in there at some angle the horizontal along the parabolic is shown, where x and y indicate the horizontal vertical velocity respectively. Show in the diagram the direction of the velocity acceleration. Okay, book page 16. See here they are given the what is the direction of the velocity, the velocity and acceleration of an object in the uniform circular motion. Okay, velocity is nothing but the tangent to the direction of the motion, acceleration towards the center. Acceleration due to gravity is always downwards. Okay, downwards. A ball is from the roof of the angle 45 degree above the horizontal to hit the ground in few seconds later. At what point during the motion does the ball have greatest speed before it hits the ground? Smallest speed when the highest point is reached. Greatest acceleration, constant acceleration. Okay, so the answer 4.18. Constant acceleration. Okay, a football is kicked into the air vertically upwards. What is the acceleration? Acceleration is due to gravity negative g. velocity highest point is 0. A, B and C are three non-collinear, non-coplanar. Non-coplanar means not on the same plane. Okay. What can you say about the direction of the cross answer 20? Okay, you can go through the answer. Short answer. A boy traveling in an open car moving in the level road with the constant speed. The ball vertically upward in the air catches it. Sketchy as observed by the boy standing on the footpath. Okay, answer. Okay, here is the answer. For a ground based observer, so this is the moving car, the ball is projectile with the speed of this and the angle of projection theta, the horizontal as shown below. Okay, this is the answer. A boy throws the ball in the air at horizontal along a road with the speed of this much. Another boy sitting on the passing by the car observes the ball. Sketch the motion of the ball as observed by the boy in the other. If the car has a speed of, give the explanation. 4.22. Okay, this is the one. Since the speed of the car matches with the horizontal speed of the projector, boy sitting in the car will see only the vertical component. Okay, the horizontal component is same, car speed and the horizontal component is same. So only the vertical component will be seen. 13. See, these are the horizontal and vertical component of a vector. Okay, horizontal is cos theta, vertical sin theta. In dealing with the motion of the projectile in there, we ignore the effect of the air resistance. And this gives a trajectory as a parabolization. What would be the okay? Show the answer 4.23. Okay, they have given the answer here. You can go through it. In the book also there is a information. 15. So here the effect of the air resistance they have mentioned. Okay, you can go through it here. A fighter plane is flying horizontally. There will okay. This speed at what angle? Side with respect to horizontal. When the target is seen, should the pilot drop the bomb? Okay, at what angle is reached? 4.24. So they given this is the angle, so you can go through it. Okay. Earth can be thought of by a sphere of radius this much. Any object or a person is performing a circular motion. So what is the acceleration of the okay? So here this is the uniform circular motion. What is the acceleration and what is the direction of the acceleration? 4.25. Okay, this is acceleration 17. So here this is the acceleration. Okay. Okay, you can go through this. Given below the column 1 and we have to match with the column 2. A plus B equal to C. Okay, as I said, how to add two vectors. From the starting point, the resultant vector should start from the starting point A, B, and the resultant here. This one is correct. Similarly, you can go through this A minus C equal to B. That is this. B minus A equal to C. This is one. Okay, A plus B plus C equal to 0. That is the second one. Okay, because they are in opposite direction. Resultant vector is in the opposite direction. If this vector goes here, this here, the result should go from the here, but it is so A plus B plus C equal to 0. The magnitude of A and B is given. Then match the resultant column on A dot B equal to 0 means A dot B, okay, is cos theta. Okay, the dot product is AB cos theta, and this will be 0 when theta is 90 degree. Okay, that is 90 degree, and it is maximum when theta is 0. Okay, because cos 0 is 1. Okay, this is off when theta is 60 degree. Okay, so that is why 4 into 2 8 half of 8 is 4. Okay, same way this is negative 1 when theta is minus 180 degree. Okay, similarly when you say A cross B, this is sin theta here. Okay, sin theta, it is 0 and theta is 0, because sin 0 is 0. This is maximum and theta is 90. Okay, this is off when theta is 40, so when theta is 30 degrees. Okay, 45 degrees 0.707. Okay, a ball. Okay, these things you can go through the answers. Okay, the 4.29, they have given the answer. Okay, see, some of this formula they used from the motion in a straight line. Okay, so you have to be familiar with that formula also, kinematic equations formula. So all the answers are given. 31, for this. So okay, you can go through it. And this from the net also you can see the answers. This is projectile motion. Okay, you try this without memorizing, using the formulas given in the book. You can try these problems. Okay.